you can see the online compiler. It's the repl.it. That's my actually link. I just create the account myself. It's a free account, so you can use the online compiler. And I remember last time when I tried to make a change to my code, and no matter what the change I make, sounds like the compiler doesn't recognize my change. I always stick with the old one. Now I that I somehow accidentally changed the class name. Okay, and that class name, if I change the class name, say the class name over here in this example is a main, M-A-I-N. Main is the class name, and I accidentally changed the class name to something else. And then, because in Java, the class name should match the file name, right? So you may realize that if I change the class name, which does not match the file name on the left, it's a main.java. So if I use the name main.java, then the class name has to be main. Okay. So if I change the class name, then typically, in most of the Java compiler, you're gonna point out the error message, say the class name and the file name mismatch or whatever. But in this particular compiler, it did not actually point out the error. It just simply ignore any change I'm actually making. So just let you know. So now here's the piece of code I have. I have a class name called main, which is the same as this one, and then I have a main method. Okay, so everything is a main. So then I have an integer I and x. So I equals 5, assign 5 to I, and the x equals I plus what? I plus plus. So basically, I plus plus is the Java's shortcut for I equals I plus 1. Okay. But you can simply use I plus plus to represent this. And then I can actually print out x equals x. That's a string I printed. That's the value I print, x. And then another string and another value. So if I run, yeah, you're going to give it the output x equals 5, I equals 6, because I is actually equals I plus 1. So if I change the value of I to 10, and then I run it again, so then the value of x is going to be x is going to be 10. I will be 11. So do you recognize this code? So it sounds like a very strange. Y x equals 10, because this is an assignment. I assign I to x. I equals 10. So I assign I to x. After the assignment, then I incremented I. So these one statement is equivalent to two statements. It's the same as x equals I and I equals I plus 1. So these one statement is equivalent to these two statements. Okay, but that's just the one thing I want to point out, and why last time I got a problem with my repl.I compiler. So no matter what I change I made, it doesn't affect the result. So that's because I changed the name of this class. It was really a mistake. Okay, so when I actually talk, I can actually use this compiler. Zybox has a compiler, but Zybox compiler is in the exercises. So if you want to compile your own code, so you have to go to the Zybook or go to the right section and put your code in there. It's very inconvenient. So that's why I use the repl.it. The other two compilers, the offline compilers I just mentioned was NetBeans and the Eclipse. These are two offline compiler. So the offline compiler is good because sometimes if you have a no internet connection, that you cannot use the online compiler. So you have to use the compiler on your laptop. The bad thing is that you have to install this as a software application. Okay. So let's actually continue with the topic of today. So last time we actually talked about the very basic, syntax for the Java. We also talk about the two, different type of languages. One is statically typed language. The other one is dynamically typed language. Now the Java is a statically typed language, which means that when you actually declare, when you actually use any variable x, you have to declare it. So if you just say a variable x, if I want to use the variable x, I have to declare it. I have to declare this. So when I use it, I have to declare it. For example, I declare x as an integer. Okay. Then before I can assign an integer value to x. Now for Python, there's no such an issue. So you can just declare a variable. No, you don't have to declare a variable. You can directly use the variable and assign a value to the variable. Now, what's the type of this variable x? It's dynamically typed. That means the type is dependent on what kind of number is assigned to it. If you assign 2, which is an integer, then x is integer type. And later on, once you finish the job, then you want to assign a floating point number, 7.31 to x. Now x becomes a floating point type. It's not an integer type anymore. So you can actually dynamically change the type of the x for Python, but not for Java. Once you declare x as integer in Java, then you should always use x as an integer. Even though you assign a floating point number to x, it will force the conversion. It will eventually convert the number to integer. Okay. Now, for most of this section, chapter 2, I'm not going to spend much time because the topics in chapter 2 are very similar to the topics in Java, in Python. Because when we talk about identifiers, now the Java identifiers are very similar to Python identifier. So the identifier is any, it's basically a name created by a programmer for items like variables or method. So then you need to declare identifier. So identifier must be a sequence of letters, underscores, dollar signs, and digitals. So you can only use these characters to define an identifier. So now, when you declare identifier, the identifier has to start with letter, underscore, or dollar sign. So you can say x1 is a legitimate identifier, and my name is another good identifier, and number of people, that's a good identifier. So you can actually put the dollar sign at the very end. That's fine. That's a legitimate character in identifier. But you cannot actually start the identifier with number. So you cannot say 2ND second. That's not an identifier because you cannot start with a number. You can start with letter, underscore, and a dollar sign. Okay. Identifiers are basically case sensitive. So that means noun cats and the noun cats, the second noun is capital N. These are two separate, different identifier. Okay. So many actually reserve the words like int, short, double, and some words. You cannot use this as an identifier because int is actually used to declare an integer type, right? So you cannot say I use identifier int. The int. That's not true. That's not correct. Okay. Now I don't know why I just mentioned this in Python, but there are two actually just a naming convention for the identifiers. One is called a camel case. The other one is called underscore separated. So, so because when you name identifier, you have to make sure this you use the uh, meaningful. You create a meaningful identifier. That means the identifier should be descriptive. Okay. So, for example, if you say, okay, how many people in the class? Okay, how many students in the class? You can say use identify like a number of student in the class. And you can use num student. Okay, so that basically represent number of students. Okay, so try to make it meaningful. And the camel in a camel case, now if you actually um, in the camel case, you basically use the use actually a couple of words, use multiple words to form an identifier. But you basically capitalize each word except the first one. For example, number of students, you can say num student. Okay, say people on bus, so you can use that. Number of apples. Okay. Also, you can actually say number of student. That should be fine. That's a legitimate identifier. But compare with this, looks like it's too long, and it takes time to write it, and also it's very long. So there's actually some kind of trade-off between this and this. In here, you use acronym, I use abbreviation, but here you just use the whole complete sentences. And this is a camel case because you have, each word and start with a capital except the first one. Okay. Now the other type of other convention is use the underscore. So for example, number of student or num apples, you can use num apples. Now instead of using the capital A, you use the underscore to separate two words. People on bus, you use underscore to separate the words, but now you use all lowercase. Okay, so these are two conventions. It's hard to say which one is better, which one is not. It's up to you. You can adapt with one convention, but try not to mix both. Mix actually these two different convention, and sometimes you use a camel case, sometimes you use underscore separated. In most of the company, they have some kind of rules that all the code in the company have to use the camel case. Then everyone use the camel case. Okay. Now here's a good practice. Create a meaningful identifier. Minimize the use of abbreviation in identifier. Abbreviation is sometimes good. Just you can actually make the word shorter, but sometimes it's confusing. For some of the words like NASA, well, abbreviation serves well. But if you use the abbreviation FSU, I think I can understand this, and probably you. I think you can understand this, but if you try to actually do this in the company in other places, people are going to be confused. You know, FSU could be a Florida State University and a Fitchburg State University, Framingham. You know, so you can interpret in different ways. So that's confusing, but you know use the abbreviations very carefully. And also you need to find a balance between abbreviations and the long variable names. Okay, so over here, num students, a number of students, that looks fine, right? Even though we use abbreviation, but you're never going to be misunderstand what you try to do, so this is good. Now these are list of the Java reserved word or a keyword. Don't use these word as identifier. If you want to define any variable, don't use any of these, okay? Because these are keywords. These are reserved. Now for arithmetic expressions, I'm not going to spend much time on this because this is pretty much similar to Python or most of the other computer language. Okay, now we use the same notation. Plus means addition, dash means subtraction, asterisk means multiplication and division. And so you can use this, and you can also use the parentheses, just like write math expression in in your math class. So and also for each of the operations, there's a precedence rule. Okay, now this precedence rule is very similar to the precedence rule defined in math. For example, if you have a math expression, when you say, okay, I want to write the math expression, say x plus y times 2 divided by z minus 25 or 28. That's a math expression. Now, when you actually try to evaluate this value, then you need to assign a value to x and y and z. Then you can calculate the value. Now, what's the precedence rules for this? Which one you're going to evaluate first? Okay, the general rule of thumb is if you have a parentheses, always evaluate the expression inside the parentheses first. Okay, now for unitary sign like a minus, then always evaluate this, and then you can evaluate the order going to be multiplication, division, and the modular operation. So I will talk about the modular operation later. Okay, and then the plus and the minus. Now also, if you have a more than operator of equal precedence, for example, you have a long actually expression x plus y minus z plus k, you have a couple of actually plus and a minus, and these are basically at the same precedence, then you're going to actually the order going to be from left to right. Okay. So for this particular case, which one will be evaluated first? The one
it would be the division inside the parentheses, so 2 divided by z.
Okay, so first inside the parentheses, that's the first expression you need to evaluate. But inside this parentheses, you also have two operator. Now you're going to actually evaluate the division first, right? Because division has higher priority than minus. So you can evaluate the 2 minus z first. And then this whole expression, right? 2 minus z minus 28. Then what's next? Then y multiply this because multiplication has the higher priority than plus. And then this is the last one. Okay. So you just know this general rule, right? So I don't want to spend much time on this. Okay. So if you have any questions, then you can actually read the corresponding section in Zai book and perform the exercises. Just practice these exercises to make sure you understand this concept. Okay. Now the next thing we're going to talk about is a data type. Okay. Now, just like any other language, Java, like a Python or C, Java has various different data types. Now we already talked about the integer type, okay? And when you actually import the integer type, you use the scanner next int. Now there's another type called a floating point. The floating point number is a real number containing a decimal point, okay? So it's going to look like a 98.86, 0.00001, or 55. I'm sorry, 55.667. So now the widely used actually floating point type is a double in Java. Okay, double is a floating point type. Okay, so you can say, okay, if you actually use the floating point number, then you can say double x, and x equals 3.14. Okay, so that's the floating point number. Now, when you use the scanner to import the value from the keyboard, then you can, instead of using next int, you can use next double. Okay, so then you can type the floating point number. And also Java supports the scientific notation. Okay, now the scientific notation is actually used to represent, to express a very, very big number or very, very small number. Okay, now one of the example is like this. Now 6.02 times 10 to the 23, right? That's a huge number. If you don't use the scientific notation, that's going to be a nightmare. If you try to express that number, it's going to be 6.02 0.0000000. How many zeros? From this point to the end is total of 23 digits. Okay. So 0, 2, 0, 0, 0, 0. Now you have actually 21 zeros afterwards, plus these 2 digits. That's a nightmare. So you don't want to do this. So you have to, so that the easy way is to do this. Now the other example is like if you want to represent 0, 0, 0, 0, 0. One, two, three. That's a this is a very small number, right? It's close to 0. But you know, sometimes if you're trying to represent the weight of an atom, it's very small. Then you have to use this. Now, what is this? This is a huge, small, extremely small number. But if you use the scientific notation, you can just say 1.23 times 10 to the what? Let's see. How many zeros? 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13. Okay, 10 to the 4 to the minus 14. So because it's all after the decimal point. That's a scientific notation. Now Java allows you to express this using scientific notation. Now for this one, you can use 6.02. E basically means point of 10 exponent 23. And what about this? If you use, what about this? If you use the Java to represent this, you're going to be 1.23 E minus 14, right? So scientific notation is used for representing floating point numbers that are much greater than or much less than 0. Okay, so This is actually, these are two good examples. Now, also in Java, you sometimes going to use some constant number. Okay. Now, these constant number, you can actually use the constant number. For example, like a pi. You use pi equals 3.4. Okay. Now, of course, pi is not English, so it's a so that's why I use pi. Okay, pi equals this. Now, of course, you can just directly type a number, but it's kind of not convenient, because if you say I want to calculate the area of a circle, so the radius is r. Okay, so I'm gonna say, if I just say, what is the area of the circle with radius r? And
Is it pi r squared?
it's a pi r squared, right? So now if I use Java to represent this, to write this, I'm gonna say I'm gonna say double r, and so I'm gonna import the r, use a scanner or whatever. I'm gonna say r equals, I use assignment, r equals 4.0, and then the area equals pi times r squared. So I can use pi, just directly type pi times r times r squared. I can use multiply r twice. Okay. Now this is one way to do this, but if I actually have to use the number pi again and again and again, so in that case, what I can do is I don't have to write this. I can declare, a pi as an integer. Oh no, integer, not double. I'm gonna say double pi equals. Now, since pi I use as a constant, I don't want other people to change the value of pi. So then I can use a special keyword called final. So I'm gonna say final double pi equals this, and then I can just say area equals pi times r times r. So in place of pi, you're gonna replace with 3.14.15926. Okay. Now,
Professor, isn't there also I saw this in the homework. I think it was on SciBooks. Is if you in the math module, there's actually like a built-in pi.
Oh yeah, you can. That's a good point. Then if you actually cannot remember that number, you can always do this. Then you can replace the pi with math dot, right? Is a pi, right? Correct?
Yes.
Yeah. That's another good way. That's even better, because now you don't have to remember what the number is. Yeah, that's another way to do it. But
is that more exact?
Yeah, I think it's more accurate. I don't know whether this is double precision or single precision. For double precision, yeah, it's more accurate than this one, because pi is not a rational number, so there's no end for this. It depends on, you can actually. I think this is pretty accurate. You actually the accuracy is actually all the way up to like 7 digits. But sometimes you want more actually precision, then you can just put more words. I cannot remember the rest of this, but maybe math.pi can actually give you more accurate number. Yes. I just want to actually show you how to define a constant variable, because you want to define a variable and assign a name, but you don't want other people to change it. Because if I define as a final double pi, and then people say pi equals 2.7, then you got a compiler error. Okay, this is not gonna allow it because you define the pi as its final, but you try to change the value. Okay, that's basically the point I want to make. Yeah, a math method. Okay. So most of the computer languages, they have a built-in methods, mostly math method. So they build in this method and put in the library of this function. So you don't have to define the functions by yourself because you can simply use them. Okay. So, a couple of math methods are, like square root, POW, which is power, not prisoner of war. ABS, that's, so that's basically absolute value. Okay. Now, if you actually write, say, I want to calculate the square root of 4, then you can just say, I define the double x equals math. Always put the math at the beginning, dot that's a square root of 4. And then as you assign to x, so x get the 2.0. So and the power is basically calculated x to the y. So sometimes if you want to say x squared, then you can use the 6.0, math power 6.0 comma 2.0, that basically going to do the 6 2.0. So 6 squared, that's 36.0. So but in this case, you can just, sometimes people just simply instead of x squared, you can, instead of using power method, you can use just this, say x times x. If it's a square, then you just type. But this math power method is so powerful because you can actually, x and y could be anything. So if x squared, then you can say x times x, right? So you can also use the POW x 2.0, and you can put the math over here. You can use this for square, which is not big deal. You can just simply just times x twice. But what about this math dot POW and 6.0 2.1? So 6 to 2.1, that's a really interesting number. Now you can also use the power to represent a square root of x, right? So in this case, you can use for square root of x, you can use the math dot POW x 0.5. Okay, so that's x to the 1/2. That's the same as square root. But in that case, I don't recommend you to use this. Use this one instead, because this is slower. POW going to be slower than the square SQRT. Okay. And you can also use some other methods like a trigonometric method, like a sine function. And also you can use the logarithms. There are so many actually different math methods you can use. Okay. Now for the absolute value, you just give you the absolute value. So in math, it's just like x. Now one thing you need to actually be careful about is the division. Okay. Because when you actually multiply, if you have multiplied two numbers with the same type, you can still keep the type, but division is different. If you say, if I divide 3 by 2, okay, what do you expect to see? In math, if it's 3 divided by 2 equals 1.5, right? That's a math. But in a computer language, using Java, if you say 3 divided by 2, now what this going to give you?
It's going to give you 1. It throws away everything after the decimal.
It will give you only 1. If you try the exercises in Zybook, you'll find out. Why? Let me explain. In Java, because it's a computer, it's not a human being. The computer is not really smart. So it just do whatever you ask the computer to do. It's just doing things faster, not smarter. Okay. So in this case, when Java actually try to evaluate this expression, the Java going to check the first actual operand, which is 3, which is integer, right? And then you have a division, and then you check the other type. It's also integer. And then Java going to think, okay, I divide integer by another integer. So I got 1.5, which is not an integer. Okay. It's a double or floating point. So the Java say, you actually operate on 2 integer. So I assume that you're going to, basically it's not the Java who assume this. It's the people who develop Java program who assume that if you have 2 integers, then the result should be integer. So then you're going to convert to integer. Okay. When you convert a double a floating point number to integer, you're going to throw away the digitals after decimal point. You threw away the fractional point. Okay. So that's basically the result you would get. Okay. Now, in order to force the Java to do the right thing. Now, sometimes this is intentional. Don't get me wrong. Sometimes people actually intentionally divide one integer by another integer, and then people actually mean to get only the integer portion, the whole number portion of the result. They intentionally want to drop the decimal point, but that's fine. But sometimes it's a mistake, because people misunderstand this. I thought that this 3 point divided by 2 is 1.5, but it's not, because Java can interpret this. Now, in order to avoid the mistake, you can do what? You can change the type of each of these number, right? Now, if you type 3.0 divided 2.0, then the Java think, oh, this is actually floating point. This is another floating point. So it's 0.5. It's a floating point. That's correct. So I keep that one. Okay. This is fine. Okay. Now, there's a lot of actually confusing part because in the language. So when you do the practice on this some of the exercise, you will slowly learn how this is going to work. Now, what about if I say I define x as an int, and then x equals 3.2. So 3 divided by 2, which is 1, right? Because 3 is integer, 2 is integer. So 1 assigned to x, because x is integer, so x got 1, right? Not a problem. Now what about this? What is the value of x? So 3.0 divided by 2.0. So now it's a floating number, and this is a floating point number. So the result is 1.5 floating point number. Then it's a floating point number, that's fine. Then 1.5 assigned to x, which is integer type. X will be 1. Okay. Don't get me wrong. Because when you assign, because x is declared as integer, when you assign any other type to x, the Java gonna actually do the type conversion, convert whatever the type to x. In this case, convert the floating point number to an integer. So you're going to drop the numbers after decimal point. Again, you get the same result for different reason, because here it's already 1 and assign 1 to x. Here it's 1.5, but assign 1.5 to an integer type. So eventually you got a 1. Now let's actually try another case. Double y. So y equals 3 divided by 2. What the value of y going to be?
Would it be 1.5 because it's a double?
Okay, because y is double, right? Now look at this. 3 is an integer. 2 is an integer. So 3 divided 2, you got a 1.5, because 3 divided 2, integer. So the result is going to be integer as well. So this is going to give you 1. Okay. Now 1 going to assign to y. Y is double. So eventually y get 1.0. See the point here? That's confusing, right? So that's why I want you to practice a lot on these Java type conversion things, So this 3 divided by 2, it's, keep that in mind. 3 divided by 2, the result is already 1. So now you assign 1 to y, but 1 is an integer assigned to a double. That's okay. So then you just add a 0.0. Okay. Okay. Now I think this makes sense. So in order to actually make things consistent, I always recommend don't make things confusing. So this is the correct expression, and this is also the correct of expression, because both sides, this is the integer, everything is integer. This is a floating point, and a floating point. Now, if you try to do this, technically you can't do this. However, you should actually realize there might be some unexpected things to be happening, because Java going to make its own decision. If you actually have any kind of type mismatch, then Java going to try to correct it. The way that Java going to correct it may not be the same as you understand it. So that's why you need to practice this a lot to understand how the Java going to do the conversion. Okay. So unfortunately, I cannot include all the different cases in this type conversion things, but just actually with the integer rounding, when you do the division for 2 integer numbers, you can actually get rid of the decimal point part. So, but on the other hand, so one thing is that you try to convert the integer to that double. This part is probably okay, because you're not going to lose anything. Because if it's an integer 2 converted to double, you just add 2.0. So 2.0 is, from math perspective, it's the same as 2, right? Now the other conversion is dangerous. If you have a floating point number like a double, you have 2.51, and you just convert to integer, then you're going to lose the information, because you are not going to be able to save exactly the same number. It's not 2.51 anymore. It's actually 2. Actually, it's actually 2, right? So you must be careful about this. Now, this is actually the operation called a modulo operation. Okay. Use the percentile. the modular operation is the operation that when you actually say 24 modular 10, the Java going to do the division 24 divided by 10, right? So then you're going to 2, that's a quotient, 20, and then 4, that's a remainder. So this is actually the remainder. So 2.24 modulo 10 is 4. Okay. Now 50 modulo 50, that's 0. Why? Because 50 can be divided by 50. So there's no remainder left. The remainder is 0. And 1 modulo 2 is 1. Because 1 divided by 2, you got a quotient of 1, remainder 1. Okay. So that's a remainder. Okay. So the modular operator evaluates the remainder of the division of two integers. Just keep that in mind. Okay. Sometimes in certain applications, it's very useful. Now, so here we're going to talk about the type conversion. Okay. Java going to actually perform the type conversion. In some case, the type conversion is not possible. If you want to convert a string, a character to a number, that's not possible. But you can actually convert between decimal integer and a floating point number. Okay. So type conversion is a conversion of one data type to another. Okay. So the Java compiler going to automatically perform several common conversion between int and double. And these are called implicit conversion. Now, everything we performed here is actually supposed to be implicit conversion. Okay. Sorry. So, for example, if you actually convert int to double, the 25 will become 25.0. So if you define double x and x equals 25, this is going to perform the int to double conversion because this is an integer. 25 is an integer, and convert to assign to x is double. So you're gonna actually eventually x gonna be able to 25.0, not 25 anymore. When you store it in there, it's 25.0. Now, double to integer, as I mentioned, this you must be careful about this because if you have a integer x type and then x equals 2.512, that's a double assigned to the integer, then x only get x, the value of x going to be 2. Okay. You're going to throw away the decimal point. So that's called implicit conversion. Now, try to avoid it because this is always confusing. Even Java gonna do the job, but it's confusing. Sometimes it probably gonna perform some kind of weird things. Okay, because it's not gonna actually give you the answer you expect it gonna be, unless you intentionally want to do that. Okay, otherwise don't do that. Always, when you declare as an integer, I will always assign integer value. Now, if you really want to convert the type, I think a type casting is a one of the approach. It's a very good approach. Okay, so for example, if you just say, if say double x int y, x is a double type, and then x equals 2.5, which is fine, and y equals x. So then y will get 2, right? So This is an implicit conversion. But if you want to do this, I recommend you do this. You just type y equals that's called casting. So even x is 2.5. After you cast the int, you're going to force the value to become 2. So then assign 2 to y. So now, technically, y equals x, and y equals int x. Technically, they're going to do the same thing, okay? But this one, sometimes people are going to be confused. And this one, it's clear. It's explicitly convert the number. So that's the casting. So sometimes using the casting, even though without using the casting, you get the same result. But do use the casting because this is gonna emphasize the point. Okay. I'm gonna skip this for now. This is gonna actually later on, I'm gonna talk about the binary numbers. Okay. But right now I want to skip that one. So just keep that in mind. I'm gonna be back, and I will quickly introduce the other type. One is called characters. Okay, so a character is another type, which is not a number, numeric type. Okay, so if you want to say I want to assign a character, I declare a character type using char, and I x. So x is a character type. So I can assign x equals a single quote. So that means x is assigned a character type. So x is a character type. Okay. Now, if you actually want to import the character type, there's no actually a scanner method. If you use the scanner, try to import a character, then you can use this scanner dot next. You can use the next and then dot character at. So it's kind of confusing, right? But this is just keep in mind this is gonna actually import the character, to the. But we will explain this later. Why we use char at 0. Okay, that's something we're gonna talk about later. Okay, so this is a character type. Now the other type we talk about is the string type. Okay, now string. So if I do this, I'm gonna say string. So then I can assign x, say Brady, space, Chen. Now x is a string type, and I can assign a string of characters. Okay. Now string type allows you to actually import a sequence of characters. Okay. Now the difference between string and a character is only one. A string you can have a multiple, but that's not the only difference because character use a single quote, string use double quotes. They're slightly different, We'll talk about this later. Okay, again. So the string type, string allow people to actually to import a string. So you can use a various different one. Inside you can even use $, percentile. So here's another string: $1, $100 for Julia, factorial, and then if you actually include with the double quote, that's sorry, that's a string type. Okay. So you can, when you print out, you can always print out a string type. Print out a string hello, then you're gonna print out this string type. Okay. Now, one thing I'm gonna talk about on Monday is the string variable. When you declare a string variable, so you can declare like an integer. So x is the integer variable. You can declare double. Double is y is double integer, and then you can declare string z, and string z is a string type. And now, what's the difference between them? So you define different type, but also there's a major difference between string variable and the other type of variable. Now, x and y, these are it's called a numeric type, and it's called a primitive type. Primitive type data. Now, string is called reference type. Okay, we're going to discuss this later. Okay, what's the difference between reference type and a primitive type? Now, because primitive type, it's a fixed size, like an integer, it takes 32 bits. Okay, you're going to take 32 bits for the integer. Double, you're going to take 64 bits. That's the space I can reserve for this integer type and or double type. But for string, if you declare z as a string, how much space are you going to reserve for string type? You don't know, right? Because you can have a very extremely long string, you can have a very short string. How much space are you going to assign to the string type? So that's the reason why for the string type, you can assign a string as an object, store the string somewhere, and the string type actually refer to the object. Okay, so that's something why it's called a reference type. That's something we're going to talk about later. And for the string, you can actually use use a scanner. Scanner is designed to import a string. Say scanner, SCNR, and you can have the first one you can use scan scnr.next. The next is a method that you can use to import a string. You can use next. Okay. Now, if the import string is hello there's a space here, then the string 1 will get hello, string 2 will get there because there's a space here. Okay. So if you would like to put the whole, now if you want to say, if I want to assign, if you actually put the hello there, and I want to assign the whole hello there into string 1, what are you going to do? So then in this case, you're going to use the next line. So that means the whole line of string going to be assigned to S1. But otherwise, if you use next, it just actually import to the first string. And once you see the actually space, then you're going to stop. Okay, so that's something we're going to talk about this later. So the best way to learn is to use practice. So I'm going to stop right here. We still have 15 minutes. So I would like you to log into a different group. Let me actually show you what is your group. If you go to the Blackboard, for this class, if you go to the Blackboard, you can find, I actually formed 3 groups, group 1, 2, and 3. And so group 1, it's Noah, Joshua, and Stephen, and Andrew. And the group 2, Alicia, Richard, David, and Ryan. And group 3, David, Roselle, and Ashley, Tyler, and Lucas. Okay, so these are 3 groups, and each group has a Google Meet link, which going to lead to a different Google Meet room. Okay, I call different rooms for your Google Meet. So these 3 are going to be dedicated links for your group. So the idea is, I want to actually, each of the group are going to be active. So many times I'm going to give you some kind of assignment in the discussion. forum, I'm gonna say, please actually read this. Each individual read this chapter 3.1 to 3.5, and then you're gonna discuss any of the issues, any problems in these sections, in these chapters, and then you can actually put together certain of the questions you have, and then you can post the questions on the discussion forum, so I can pick the question in the class. I want you to be, engaged in class instead of me just talking the whole class. I want you to actually, frequently meet together using that Google Meet link. Unfortunately, because the COVID-19, that's the only way we can actually form the group, and the Google Meet is probably the best way we can meet each other. So right now, the first meeting, I don't have any agenda. I don't assign any job, but I want you to, each of you, just find out your link and log into the Google Meet link and chat with your members. And you're going to be the group for the whole semester, so you can chat to each other, get to know each other, and then later on, when I assign any kind of reading assignment, ask you to post a certain of the problems, then you're going to do it. And one thing I want you to do is I want you to actually select a team leader for the group. Now you can switch the team leadership. The first time maybe Noah could be the team leader, and the next time Steven could be the team leader. So you can actually, it's up to you. You can just actually discuss to each other and take a turn as a leadership. Okay. So I'm done here. So I'm gonna mute myself, and then I'm gonna actually switch back and forth between these three actually Google meeting rooms. So you can you can stay here, but you can log off and go to the different room. Okay. Yeah, please actually go to the Blackboard if you don't know the link. Okay, let me actually just post on these. Okay. Okay, I just posted the link on in the class actually Google Meet room, so you can click each of this, go to your link.
Can we leave this room, Professor?